Okay, so 4-7, last section. We're going to look at overlapping triangles. So there's all different kinds of triangles and drawings that they could give you where the triangles are overlapping and they're no longer just touching or separate from each other. They're part of the same drawing. So let's look at the review. Circle the common side of the two triangles, just even without looking at the picture. ABC and ABC. What letters do they have in common? A and C. And so wouldn't their common side have to be AC? Circle the common side here and the common side here. So do those on your own. So what did you get for number 2? WZ, and for number 3, RT. So you can do some of those things with a picture. And then our word for the day is overlapping. I'm sure you don't know what that means. Nope. Overlapping just means the figures have certain parts in common. It could be angles in common, it could be sides in common. Most likely it's angles in common. So we're just going to look at one of these, not all 4 of them. But if you look at question 4, look at the triangle FGD. And then look at the triangle CBE. So they are overlapping by this amount right here, agreed? And so we want the common region. The common region happens to be a triangle. So isn't triangle EHD? So it'd be this one here. And this is just an example of a picture. They don't all look like this. So we're not going to do the others, but you get the idea for that particular picture. For problem 1, what is the common side in triangle ABD? So I'm going to highlight, and for some of you this might be a good plan. It's hard for you to see it. But I'm going to highlight ABD. So from A to B to D would be that triangle there. And then DCA. So these triangles share a side, don't they? True or false? Yeah, and you can see that through their triangle congruent statement. And one of the things that I would suggest, and what they're suggesting here, is to separate the 2 triangles and redraw them oriented correctly. So I'm going to draw them so that they look like the triangle in yellow. So here's the yellow triangle. And I don't know that that's a right angle, so I can't put a right angle here. But I do know that that's B, this is A, and then D is over here. I'm going to draw the second triangle, oriented exactly the same. What do you think corresponds to B? C. What do you think corresponds to A? D. And they haven't quite given me a congruent statement here, so I can't necessarily assume that those are the corresponding angles. But it appears that that is what they have done. And so then I'm missing A. A belongs here. So now I've taken them apart from each other. You can see that they do share this side AB. Obviously, angle D on this triangle and angle D on this triangle are not the same size angles, correct? So that we cannot make the assumption of. And that's all the information that they've done is just they want you to identify common parts. The only part that they have in common is that side. So you drew side AB twice, so the common side is side AB. And you might not need to redraw it in order to see it, but some of you do. Problem 2. This time you're given that triangle ACD is congruent to triangle BCE, or I'm sorry, BBC. I said that wrong. So ACD is right here. And BBC is here. So it's very similar to the previous picture, is it not? So what part do they have in common? CD. Your job is to prove that CE is congruent to DE. So we want to prove that CE is congruent to DE. So that's completely different. This is a tougher proof. So here we go. We know just by looking at the picture, don't we know that CD is congruent to CD? By what property? Reflexive property. We also know that triangle ACD is congruent to triangle BBC. And that also means that all corresponding parts of those triangles are congruent as well. So all 6 corresponding parts. Just based upon that. So in order to prove that CE is congruent to ED, I'm going to have to prove that AD is congruent to CB, and somehow prove that BE is congruent to AE as well, so I can get those parts taken away and just be left with these, because this is only half of a side. So we're going to fill in our need here as we go through the proof, so you can see maybe why we need that, and the next time we go to another proof, it'll make a little bit more sense. So look at how they progress their proof. We're going to start with the only given that we have. And the only given that we have is triangle ACD is congruent to triangle BBC. That's our given. Then they start off with AC, that's this leg right here, and again, if we redrew the triangles, so I'm going to redraw the triangles up here, just so you can see the parts. This would be A, C, D, that's the yellow triangle. And I'm going to redraw the pink triangle, so it's oriented correctly. What corresponds to A? We've got a congruent statement. B, so B has to be up here. What corresponds to C? D is in dog. So that leaves us with C. So they're saying that AC is congruent to what? And it would have to be BD. All corresponding parts of congruent triangles are congruent. CP, CP, C, right? And our goal is to get to, now I don't have E on this picture, but our goal, we've got BC, this side right here. Those are the sides that contain point E, and somewhere in here, like right here would be point E, somewhere in here. So somehow we have to get those into the proof. Then they've got angle A is congruent to what? So A is congruent to angle B. And that's the same thing, CP, CP, C, corresponding parts are congruent. Then they go to vertical angles are congruent. Let's see why that is. Which vertical angles are they choosing? BED. From angle B to E to D, would that be this one right here? What's its corresponding vertical angle? So we've got angle AEC. Haven't they just created, very interesting in here, we've got this side AC, this side BD. Aren't they part of these two triangles here? Right? Okay. Have we proven those triangles congruent yet, though? Have we? These little triangles? No. So, let's see where they're going with it. Then, angle side theorem. So they're saying the triangle BED, what did we miss from here that's up here? Angle A and angle B. So they were able to say that angle A, right here, and angle B, right here, those were congruent. Based upon the bigger triangles, these ones out here. But when you look at these smaller triangles, now you've got this triangle here and this triangle here. What they've done is they've used the bigger triangles to get the smaller triangles in here that were created by the overlapping to also be congruent by AAS. That side is not included in between those two. So a note to self, gee, I can prove that triangle AC, let's use their words. So if they're doing BED, then they would be doing AEC. You might want to note to yourself, these are the smaller triangles created by the overlapping ones. And so they've accomplished that, bless you, right there by AAS. Now, can't we show that any corresponding parts of those triangles are congruent as well? And isn't our goal to get to CE is congruent to ED? And aren't those parts of those smaller triangles? True or false? Yes or no? Yep. And so that's what they go directly to is their proof statement. So their proof statement, DE, is congruent to CE. And the reason for that, again, is corresponding parts of congruent triangles. So they've used that 3 different times. And technically you could have put those two together, but they were split out, which is fine. And then off the side here, you end up with, well, they didn't do it. I probably would have done it in a different order. That's okay, that's just me. So they did in the order of SAA, which is still AAS, doesn't matter. So interesting. All right, so then flip it. Now you get a flow-through proof, and I'm not ever going to make you do a flow-through proof, but I have no issues with you filling out a flow-through proof that is already partially done for you. And one of your questions on your, correct me if I'm wrong, on your success net is a flow-through proof, but you, I mean, it wasn't bad to do, right? No, because it had the option to do it. Mariah, at my convenience, so when I'm done. And attendance office. Yep. Did you miss a detention?
No.
Oh, this one. Okay, so on this proof, you're given that side PS is congruent to side RS, and they have those tick marked. And then angle PSQ is congruent to angle RSQ. And so those are triangles within there, and they've arc marked those. Got a lot of different triangles touching and overlapping each other. Your job is to prove that triangle QPT, Q to P to T, is congruent to triangle QRT. Well, those are not the pieces of the triangles that they gave us, but can you prove these two triangles where the arc marks and the tick marks are, can you prove those two triangles congruent? They've given you 2 pieces. Is there another piece that they could be Any other parts of those two triangles that could be congruent without any help? For these triangles right here. TS is equal to TS, right? So we've got side TS is congruent to side TS by reflexive property. So that's something that could be used, and that would be an S. So you've got two S's and an A. Is that SSA or SAS? And can you prove by SSA? Nope. So it better be SAS. Is it SAS? Yep, that's include angle. So then you could prove triangle PS, what is that? T? No, I wrote all over it. PST is congruent to triangle RST by SAS. So we could do that. How does that gain me any information? Yeah, if these triangles are congruent, then based upon corresponding parts of congruent triangles, can't I prove that PT is congruent to TR? And couldn't we prove that Q, is that a Q? Or O? Is that an O? It's a Q. So couldn't we prove that QT is congruent to QT? Okay, so that gives us SS. All we would need would be one more side. And furthermore, don't we have larger triangles here? See the larger triangles here? Couldn't we prove those larger triangles congruent instead of these? Why would that be beneficial? Because if I only prove these smaller triangles congruent, that only gets me these two sides. And then I can prove this on my own. The problem is I need another side or another angle. So how about we use these two triangles instead, the bigger ones, and prove it, because I can prove that those are congruent and that's congruent. That's a side, and these angles are congruent. Instead of TS, can't I prove QS? Change that to QS. And in the same realm, instead of these smaller triangles, let's do the bigger triangles, PQS. So P will do PS, how about Q here? And then we'll do RS and then change that to Q. Would it still be SAS? I've got side, angle, side, would it still be SAS? Okay? So that'd be better because then I could prove that congruent and that congruent. And that side congruent. So wouldn't that give me, so I still have side and angle. Oh, then I have a side. So I could prove these ones congruent by SAS, giving me that and that. I'd still have to do both these triangles and the big one. Let's see what they do. So here, where do we get this information from? Given. And where'd they get this from? Given. So that's only two things. Where's this from? Yeah, so notice they're doing the ST and the QS. So not one triangle, not this one triangle, but we have to get both of those sets of triangles congruent. And so this is by the reflexive property of congruent segments. And the nice thing about your flow-through proof is, since we do have to get two sets of triangles congruent, these little bitty ones here, and then the big ones here, in order to get all of our corresponding parts, the nice thing about your flow-through proof is you can put both of them together. And so, based upon these, what did we say the triangles are congruent with? So this would be your SAS postulate. Now that all the triangles are congruent, what can we say about their parts? Yeah, so be careful though. PT and RT, PT's here and RT's here, those are corresponding parts. PQ and RQ, PQ and RQ, those are corresponding parts. So corresponding parts of congruent triangles are congruent. Same thing here, corresponding parts of congruent triangles are congruent. What about QT is congruent to QT? Yep. So that's a reflexive property of congruent segments. And now we can say that the triangles are congruent. Let's just see why. So look at the triangles here. We've got PT is congruent to RT, so that's a side. So this gives us an S. And then PQ is congruent to RQ. That's another side, so it gives us another S. And then we have QT is congruent to QT, so that's another side. So what are the triangles congruent by? SSS partial. Yes.
Because CST and RST are equal, could you say that US is
No, because it's not, oh, well, we could if we had an isosceles triangle in there, but we don't. So at this point, no. Logic says yes. At this point, we don't have a tool to say that. But it's a good thought. The logic does say yes, and I agree with you. The logic is yes, we can prove it right now. Any other questions on that? Yeah. All right, look at the last problem. You're given that you have congruent angles. They don't have them marked in here, so we're going to mark that in here. So angle CAD from C to A to D, this angle right here, little bitty angle, is congruent to EAD, this little bitty angle there. So doesn't that mean that AD is an angle bisector? And then angle C is congruent to angle E. They want you, and we're not going to go through the proof. Perhaps. Nope. So that's a nasty proof we have to do. They want you to prove that segment BD, this segment right here, is congruent to FD. So you could try to prove the little triangles congruent here that contain BD and FD. So these little bitty triangles, you could prove that those are congruent somewhere to get to that. You also have other triangles in here that you could possibly prove congruent as well. But the question is, circle the angles that are vertical angles. So start there. ADB, A to D to B, that's this angle here. Does that have a vertical angle? No. ABC, ABC. That's from here to here. Does that have a vertical angle? No. How about ABE? No. How about ADF? No. How about BBC? There you go. There's one. And how about FDE? Of course I'd wait for the last two. And that's not to say that any of those other ones weren't congruent, but there you've got vertical angles. Mark the angles that you know are congruent in each pair of separated triangles below. So they've already told us this is ABD here and ADF here. So on this one, haven't they already told us that those are congruent there? That was in the given. And so also don't forget that that means that these are congruent as well. And there's no D in this one, so we can't do that one. This one has the vertical angles here, right? And then here, right here. What else did they give you in the given? What about C and E? Yeah, so there's a lot of different angles in here. I'm gonna mark this with a red double and red double. And this would be red double and red double. What else do we know? Angles. Mark the angles. FD, which one are you looking at?
They're too small.
FDE, oh, we marked those, right?
FDC or
Which one are you looking at?
BBC and FDE are.
Yes, we marked those.
Those are your verticals.
Any others that we missed? Okay. We might be able to prove some others later on if we prove triangles congruent, but off the top of our head, there we go. Which triangles are congruent by AAS? So these ones have 2 angles in them, right? Don't they share a side also? Don't they share a side AB and AD? Oh, they don't have triangles in there, but these ones do, right? Can't those be done by, is that AAS? Is the side included or not included with AAS? Not included. Is that side there not included in between your 2 angles? Is that side in between your angles? Nope. So you've got triangle ABC is congruent to triangle A has to correspond to D, and so that leaves us with D by AAS. All right, flip it. So which triangles are congruent by ASA? So let's go back and see if we can find some other sides. Whoop. So now we want ASA. So we're missing some angles in here somewhere. So is BDA, are they congruent? Can we say that they are? And ADF? They are, but no. You can't really say, oh, you mean here? Logic says that they are. But how to prove it is the question. That bisects that angle. But it doesn't necessarily bisect these angles because if these angles are different, like B and F, I can't guarantee that those sides are the same, but there's nothing that says that those sides are the same. Facts and interest. Because you can't assume that yet, mostly because I haven't proven the triangle is congruent. If you go back, that's it. And they want you to say that these are congruent. And that's what they want you to prove. And if that's the case, you can prove your triangles are all congruent. In this one, we've already proven that ABC is congruent to ADE. So if we prove that those are congruent, and we're trying to get to these parts, then can't we prove, if these 2 triangles are congruent, think about it this way, if these 2 triangles are congruent on here, and that's these ones right here, don't they contain the littler triangles that have the vertical angles in them? So those 2 triangles there are these ones here. So we've proven those by AAS, then that means all their corresponding parts are congruent. So by this, can't we say that DE, this side right here, DE is congruent to CD by CPCPC? And wasn't this a vertical angle right there that we proved congruent? So we can prove this congruent. And we proved our vertical angles were congruent. Plus CE, oh, we forgot to mark that on here. Aren't these congruent also? C and E. So there's your ASA right there. How is that helpful? What sides are those on? Don't they contain the BD and the DF? So because those two triangles were congruent, those parts belong on those ones, we could prove that CD was congruent to DE, which we put over there. We know from the given that C is congruent to E, so these triangles are congruent by ASA. So that's going to get you to your final proof statement. So which triangles are congruent by ASA? It would be BDC is congruent to triangle, and then your other little one would be FDE. And then this is corresponding parts of congruent triangles are congruent. So because we forgot to mark the C and the E on that one, right here, we missed it. But once we mark the C and the E, and we used the fact that those triangles are congruent by AAS, we can prove any parts that are on those triangles. And the DE and the CD are part of those triangles. So we got to those using ASA. So the whole point of this lesson is that you might have to prove two sets of triangles congruent in order to get to some parts that you want to prove are congruent. And we're not going to do the lesson check today, because I want to save time for questions on last night's homework.